Okay, let's unpack this. Think about that moment of pure bliss when a cookie melts in your mouth.
Mm-hmm.
Or the satisfying crunch of a candy bar, maybe that smooth richness of ice cream.
Yeah, absolutely.
What is it about these sweet treats that just has us completely hooked?
Right.
And more importantly, what secret code are they punching into our brains that makes us crave them so intensely?
Uh-huh.
If you've ever found yourself battling a sugar craving, you're definitely in the right place today.
That's a perfect setup.
Mm-hmm.
And what's truly fascinating, I think, is that this isn't really some kind of moral failing on our part.
No, right?
There's a deep biological drive behind our love for sugar. So in this deep dive, we're going straight into the brain.
Okay.
We want to see exactly what happens when sugar comes into the picture. And we're drawing heavily from the insights in Nicole Lavina's really great TED-Ed video.
Ah, the TED-Ed video. Excellent source.
Yeah, consider this your backstage pass to understanding those powerful urges you feel.
Okay, backstage pass, I like it. But before we get all brainy, let's maybe nail down what we actually mean by sugar. Because it's way more than just, the stuff we spoon into our coffee, right?
Absolutely. Yeah, sugar is kind of an umbrella term for a whole family of carbohydrates.
Okay.
The video breaks down a whole bunch.
Yeah.
You've got glucose, fructose, sucrose, that's your basic table sugar.
Mm-hmm.
Then things like maltose, lactose, dextrose. Even starch technically fits in there.
Starch, too. Wow.
And then, of course, the usual suspects like high fructose corn syrup, fruit juice, raw sugar, honey. It's a surprisingly long list when you lay it all out.
It really is. And what really jumps out, for me anyway, is how sneaky sugar can be.
Definitely.
It's not just lurking in the candy aisle. I mean, the video points out it's often added to everyday things you wouldn't necessarily think of as sweet.
Like what?
Well, like tomato sauce, some yogurts, dried fruit, even those healthy flavored waters sometimes.
Oh, yeah, those. And granola bars.
Granola bars, exactly. Yeah. It's almost like a nutritional ninja hiding in plain sight.
It really is.
Yeah.
And given how widespread it is in our diets, understanding its effects becomes really critical.
Right.
So our mission today is pretty straightforward. Let's figure out what goes on upstairs in the brain when we eat sugar.
Okay.
And let's tackle that big question. Does eating a little sugar really open the floodgates to more cravings?
Yeah, the $1 million question.
We want to give you the clear science without getting lost in, the jargon jungle.
Love it. All right, let's talk about that very first taste then. Imagine you're enjoying a bowl of your favorite sugary cereal. What's happening the instant that sweetness hits your tongue?
Okay, so the moment that sugary cereal lands on your tongue, it activates these incredible little detectors. They're called sweet taste receptors.
Taste receptors, got it.
Yeah, nestle right within your taste buds. These receptors then fire off a signal, like a tiny electrical jolt, straight up to your brainstem.
Brainstem first, okay.
From there, the signal zips into different parts of your brain, including the cerebral cortex.
Ah, the cerebral cortex. And that's where we actually register different tastes, isn't it? The video mentions specific areas for bitter, salty, umami.
Exactly.
And of course that dedicated sweet spot. So that sugary hit from the cereal is specifically lighting up the sweet section of our brain. Makes sense.
Precisely. But the story doesn't end there with just identifying the taste. That signal from the sweet part of your cerebral cortex then goes on to ignite a really crucial network.
Uh-huh.
It's called the brain's reward system. Now, here's where it gets really interesting.
Oh, okay. I can feel a light bulb moment coming on.
Mm.
The reward system sounds like something we should definitely pay attention to. What's its main job?
Well, think of your brain's reward system as your internal do it again button. It's a complex network, electrical and chemical pathways crisscrossing different brain regions. And its fundamental job, really, is to subconsciously decide if something we just did is worth repeating.
Right.
It's constantly asking that silent question, should I seek that out again?
Ah, okay, I get it now. So that rush of pleasure, that's good feeling you get when you taste something amazing.
Yeah.
Like the video's example of grandma's chocolate cake.
Oh, classic.
That's the reward system, giving a big thumbs up, essentially saying, yes, more of that, please.
Exactly that. And, it's worth noting, this reward system isn't just about food.
Right. Other things trigger it too.
Yeah, socializing, physical intimacy, even certain drugs can flip that do-it-again switch.
Okay.
However, as the video points out, and this is key, if we constantly overstimulate this system, it can lead to problems. Things like losing control, intense cravings, and even needing more of the trigger, in this case, sugar, to get the same pleasurable effect. That's increased tolerance.
Increased tolerance. Got it. Okay, so the sugar has had its moment on the tongue, sent its message upstairs, but it doesn't just vanish, does it? What happens when it actually travels down through our body?
It's right, it keeps going. After your mouth, the sugar from your cereal or whatever it is makes its way down to your stomach and eventually into your gut.
Okay, the gut.
And get this, we actually have sugar receptors in our gut too.
Really? Not taste buds, though.
No, not taste buds like on your tongue, but they're still super important receptors. They send signals to the brain that, help us feel full.
Ah, fullness signals.
And they also tell the body to release insulin to deal with the incoming sugar.
Wow, so our gut is also part of this whole sugar appreciation society. Now, the video mentions dopamine as the major currency of the reward system. What exactly does that mean? Currency?
Yeah, think of dopamine as a really key chemical messenger. It's a neurotransmitter in our brain.
Okay.
It's like the brain's little signaling molecule for pleasure and motivation. And while dopamine receptors are spread throughout the front part of our brain, they're not evenly distributed. This is interesting.
How so?
There are specific areas with a really high concentration of these receptors. The video nicely calls them dopamine hotspots.
Dopamine hotspots? Okay, I'm noting that.
And these hotspots are absolutely central to how our reward system functions, how powerful that do-it-again signal feels.
Okay, dopamine hotspots, crucial. Now, the video makes a really interesting comparison to things like alcohol and nicotine. How does sugar stack up when it comes to releasing this dopamine?
Well, what's really eye-opening is how different substances impact our dopamine levels. Drugs like alcohol, nicotine, heroin, they trigger a massive, rapid flood of dopamine.
A flood?
Yeah, essentially hijacking the reward system, sending it into complete overdrive. This intense surge is a big reason why these substances can be so addictive, driving that compulsive seeking behavior.
Makes sense.
Now, the video explains that sugar also prompts dopamine release. But generally, the effect is less intense. It's not that overwhelming flood you see with those drugs.
Less intense, but still there. And it also points out that sugar is somewhat unique among foods in its ability to trigger this dopamine release, right?
That's a great point.
Apparently, broccoli doesn't quite have the same effect.
Sadly, no.
Which, as the video hilariously suggests, might explain why getting kids to eat their greens can be, a challenge.
Exactly right. Now, let's think about what happens when we eat, say, a normal, balanced meal.
Okay.
The video explains that you do get an initial bump in dopamine in those reward system hotspots. It feels good.
A little reward.
Right. However, if you eat that same balanced meal repeatedly, day after day.
Like leftovers for lunch 3 days straight.
Perfect example. That dopamine response starts to fade. It peaks less and less, and eventually it just kind of levels off. It's less exciting to the brain.
That makes perfect sense from an evolutionary perspective, doesn't it? Our brains are wired to pay attention to new things. The video mentioned a couple of reasons. Something about spotting spoiled food.
Precisely. Spotting potentially bad food is one key reason. A new or off taste could signal danger, spoilage.
Okay, survival mechanism.
And the second big reason is ensuring we get a range of nutrients. A variant diet is crucial for getting all the different vitamins, minerals, everything our bodies need.
Right. Can't live on just one thing.
Exactly. So, to encourage this variety, our brains need to recognize new foods and, importantly, make us want to keep seeking out variety. That's why that dopamine hit from a familiar food eventually plateaus. It becomes less novel, less interesting.
Okay, so that's the balanced meal scenario. Dopamine spikes initially, then fades with repetition because novelty wears off. But what happens when we introduce a lot of sugar into the equation? How does that compare?
This is where sugar behaves a little differently. The video explains that if you rarely eat sugar, or maybe only have it in small amounts, the initial dopamine kick is pretty similar to what you'd see with that balanced meal.
Okay, normal response.
However, and this is the crucial distinction, if you consume large amounts of sugar, that dopamine response does not level off in the same way.
It doesn't fade.
It doesn't seem to. Eating a lot of sugar continues to feel really rewarding, and that feeling sticks around much longer. It's like, well, with most foods, your brain eventually says, okay, I've had enough of that novelty.
Yeah.
But with large amounts of sugar, that off switch doesn't seem to work as effectively.
Ah, I see. So that sustained dopamine release is what makes sugar a bit of an outlier compared to other foods. The video even uses the term drug-like, right?
It does touch on that similarity.
That ongoing reward signal might explain why we can feel so intensely hooked on sugary treats sometimes. It's like that do it again. button gets stuck in the on position.
That's a good way to put it, yeah.
Wow.
And the video also makes a really important point about all those different forms of sugar we listed earlier: glucose, fructose, sucrose, high fructose corn syrup, etc.
Right, the whole family.
While they have different chemical structures, the key takeaway for this discussion is that every time any type of sugar is consumed, it kicks off this cascade of events in the brain,
Same pathway.
ultimately leading to that rewarding sensation via dopamine. It's not just one specific type that's the culprit here.
Okay, so it's not about demonizing one particular sugar, like fructose versus glucose necessarily.
For this reward effect, no.
It's more about the overall effect of sugar, generally, on the brain's reward system. And the video really stresses that it's the overconsumption, eating too much sugar too often, that can really push the system into overdrive.
Exactly. It's the frequency and the quantity that seem to make the biggest difference in terms of potentially altering that reward pathway.
Right, the dose makes the poison, kind of.
That's the critical point. And the video does wrap up by reassuring us, enjoying an occasional sugary treat isn't going to instantly derail your brain chemistry.
Okay, good to know.
The real concern arises with chronic overconsumption, which can indeed start to have those more addictive-like effects on the brain by constantly bombarding that reward system.
Okay, so let's try and recap this. We've seen how sugar in its various forms lights up our sweet taste receptors, sending signals up to the brain, which then activates the reward system and releases dopamine, that feel-good chemical.
Check.
We've also learned that unlike a balanced meal where the reward fades with repetition, large amounts of sugar can lead to a sustained dopamine response.
Crucial point.
Which helps explain why we can feel so drawn to sugary foods, almost hooked. And we've touched on how our gut plays a role with its own receptors and the evolutionary reasons behind our brain's preference for new tastes. It's all quite connected.
Precisely. It's a complex interplay. And if we step back and look at the bigger picture, how sugar is woven into so many aspects of our modern diets.
It's everywhere.
It brings up a really important question, I think, for you, our listener. Considering its widespread presence, often in foods you might not even think of as sweet.
Like that tomato sauce.
Exactly. And knowing its direct impact on your brain's reward system, maybe ask yourself, what are some mindful eating habits you might want to think about adopting, just to better navigate these biological responses? Maybe just taking a closer look at your own eating patterns and those less obvious ways sugar might be influencing your choices, beyond the dessert menu.
Definitely some food for thought there. Well, thank you for joining us on this deep dive into the fascinating and maybe slightly scary science of sugar and the brain.
My pleasure.
It's certainly given me a lot to, digest.